Dissertation on the wedge, one of humanity's oldest inventions and a fundamental simple machine. A wedge is essentially a portable inclined plane formed by two sloping surfaces joined back to back that taper into a thin edge. Dating back 2.6 million years to Stone Age hand axes, this ancient breakthrough multiplies force and splits matter to power both traditional tools and modern engineering. The mechanical advantage of a wedge is calculated by dividing the length of its slope by its base thickness. A long, narrow wedge offers higher mechanical advantage, meaning less force is required to split objects, though it must travel a greater distance. Conversely, a short, wide wedge requires much higher force over a shorter distance. In terms of mechanics, static friction and wedge angles play a critical role. A wedge exhibits self-locking behavior when friction alone holds the load without any applied force. Smaller wedge angles increase both mechanical advantage and the tendency to self-lock, while higher friction coefficients improve stability under heavy loads. In practical engineering applications, wedges are widely used for structural leveling to stabilize floors and machinery bases with extreme precision. In material testing, grip wedges secure specimens inside universal testing machines to ensure uniform stress distribution during mechanical tests. Engineers also analyze wedges under dynamic variable loading to predict failure points and optimize structural safety margins. We interact with wedges daily in compound tools that combine multiple simple machines. Scissors and knives use tapered wedge edges for precision cutting, while a shovel combines a wedge blade with a lever handle. Can opener blades act as rotating wedges, and staple tips function as miniature wedges that penetrate paper? From stone hand axes to semiconductor manufacturing, the fundamental principle of the wedge has endured for 2.6 million years across everyday tools and complex modern structures. In conclusion, the wedge demonstrates the power of simplicity. It proves that profound mechanical advantage requires no complexity, only geometry, friction, and force working together seamlessly.